Okay, yeah. So my talk today is going to be about scientific modeling and whether there's any reason to think that scientific models give us modal information about the world. So the easiest way to set up the talk is to go over a puzzle excuse me, that I apparently did 32 seconds instead of 32 minutes. So the easiest way to set up the puzzle is going to be to set up the talk is going to be going through a puzzle that should be familiar to many of you. And the puzzle gets going as soon as you consider some especially highly idealized scientific models, some models that seem to be really, really idealized. Like you might say, quote unquote, more than normal. And we'll talk about what that means in a second. But anyways, here's some familiar examples. I think the sort of stock standard favorite of a lot of people writing about this sort of issue is going to be the Lotka-Volterra predator-prey model. Here's some idealizations. You have two species, only a predator species and a prey species with infinite food, infinite appetite, and no interspecies competition and no competition between that species and other species. This is supposed to be a model of predator-prey interactions and how the populations scale relative to one another. You've got examples like the Hardy-Weinberg law for allele distribution. Here's some of its idealizations. You have infinite population size, perfectly random sampling, and again, no competition. You've got examples like Carnot's ideal steam machine, which is a physically impossible perpetual motion machine. Can't have those, right? And in economics, you've got an example like Akerlof's market of lemons, which basically is one of the papers that laid the groundworks for the economics of information. Here's its idealizations. There are only two types of buyers and sellers, perfectly ideal utility curves, perfect information, that sort of thing. Okay, great. So here's the familiar puzzle. These models, these especially highly idealized scientific models, seem to provide scientific explanations or scientific understanding. Whatever it is that they seem to provide, we agree that they're good in some sense. They're good for some epistemic good that we're trying to get. I don't care what the epistemic good is, just that there is an epistemic good. So there's some sort of epistemic good that these especially highly idealized, these especially unrealistic models seem to provide. But the puzzle arises once you observe that all of these epistemic goods are factive, right? Whatever the epistemic good that you think is out there, it typically is taken to require truth, right? You can't know something unless the thing that you know is true. You can't understand something unless you understand something that is true. So given that these especially unrealistic models represent the world in ways that are known to be false, how do they provide whatever the unspecified epistemic good is? Okay, so that's the puzzle. And just, as many of you are aware, one option in this territory is just to bite the bullet and say that whatever the epistemic good is, it really isn't factive. Elegant and Potocznik, among others, are recent defenders of that view. So I'm going to just ignore that view and just also flag that, and this is stuff that's going to come up later, that this is just like a subset of the broader species of how this puzzle tends to arise. But this puzzle, as it tends to arise for the topic of the talk, which is whether idealized models give us any modal information about the world. As the puzzle arises in other areas, with regard to modality, it arises supposedly because we're focusing on especially highly idealized models. I think that this is actually a bit of a red herring, and I'll talk more about this in a bit. But supposedly, when we focus on the puzzle for the context of what I'm interested in this talk, we're going to focus only on what are sometimes called toy models. And those are just ones that are especially unrealistic compared to quote unquote normal idealizations. Okay, and like I said, I'll see why I say supposedly in a bit. So we've got a puzzle. We've got some especially highly idealized models, some especially unrealistic models. How is it that despite being especially unrealistic, they can provide any sort of epistemic good at all? Well, here's one answer. One family of answers is like this. Let's just agree that they're idealized and hence false. And so infer from the fact that they're unrealistic, false, they're especially unrealistic and false, that when they provide that epistemic good, they provide it regarding things that aren't actual. Because how could they? If they provide an epistemic good, how is it that these things could possibly provide an epistemic good regarding actual systems, given that they're so unrealistic? They still do provide an epistemic good. That epistemic good is instead, so this view goes, regarding something else. They provide an epistemic good, an explanation, understanding of, or knowledge regarding possibilities. So this view basically is that especially unrealistic models are how scientific practice engages in modal epistemology. That's the view. And here's how it is that these things are supposed to provide us understanding or explanations or knowledge regarding possibilities. The view is that the content itself is directed at possibilities. That's really the key here, is that the content of, for instance, like a highly idealized agent-based model in economics is going to be, oh, like it's not about actual agents at all. It's instead about merely possible agents, or it's about a merely possible system of buyers and sellers. Okay, and here's another way to put it. The target of the model isn't, on this view, an actual system or the actual world, but merely possible systems. Okay, so that's one view. This is, I think, the view that is most prominent in this literature. I could give you a citation list if you want, but it's defended by, everyone. I think this is far and away the most common view when it comes to these especially unrealistic models. I'm going to call this the how possibly thesis, because according to this view, what it is that these especially unrealistic models provide understanding of is explanations. How possibly, that is, how possibly explanations, mere possibilities. Okay, here's a second view. I'm going to call this the counterfactual interpretation, and this view again starts from the same place. We're going to agree that these especially unrealistic models are highly idealized and hence false, but say instead that they don't represent mere possibilities. Instead, we're going to continue to say that these especially unrealistic models really do represent real systems, but they're just represented in ways that point outside the actual. In other words, when you have an especially unrealistic model, these models ascribe certain counterfactual behaviors to their targets. So for instance, if you have a model of ideal buyers and sellers, instead of saying that the model represents merely possible ideal buyers and sellers, instead the view is that, no, the model represents real buyers and sellers, but just says of those buyers and sellers that if they had ideal utility curves, they would behave in XYZ way. Another way to think about this is to borrow some language from the literature on scientific representation. Here I'm borrowing some language from James Nguyen and Roman Frigg, that these models represent targets as particular things, or as having particular properties. For instance, if there were if this ecosystem just had two predators, just had two species of predator and prey, and they really were such that, blah, 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 then they would behave just like the Laca-Volterra equations describe. Okay, so are these views distinct? Let me say a bit about why they're distinct, and here's a bit of autobiography. A while ago, I published this paper on counterpossibles, and James and Roman kind of complained to me about this because they were like, what do you mean the content is counterfactual? And Roman said the model is a counterfactual. And I was like, I don't understand what that means. I don't understand what it means to say that the content, that that the model is a counterfactual. I can understand when you say that the content is a counterfactual, but I don't understand what you mean when you say that the model itself is a counterfactual. And then at the same time, there's been all these papers by people saying, oh, look, these provide us explanations of what's possible, or explanations of how this thing, or sorry, how possibly explanations regarding this actual phenomenon. And I thought that was weird too, because lots of these models don't seem to represent what's possible at all. But most importantly, it seems to me like these views are distinct because there's a difference in content, right? So the first important difference between these views is that the how possibly thesis says that the content of these models are non-actual systems. That the content of the models itself is like, oh, like we're not even trying to represent anything real. That's different from defenders of the counterfactual interpretation. Also need to give a shout out to Brian McLoone, who's in the chat. He's got a paper on counterpossibles where he defends the counterfactual view briefly, and that got me thinking like, oh, hey, like, is there any reason to take one view over the other? Counterfactual thesis says, hey, look, these models do represent actual targets. They just ascribe certain modalized properties to them. That is counterfactual properties. Okay, so the first important reason I think we should take these views to be distinct is that there's a difference in content. The second reason is that there's a difference in modality, right? So we'll talk about this in a bit, but it turns out, I think, that a lot of the counterfactuals that are involved in the counterfactual interpretation are going to be counterpossibles, right? Like you can't have like a hungry 1/8 of a fox preying on a poor, suffering, victimized 1/8 of a dove, right? Like you can't have that, right? Like that's a metaphysical impossibility. So it seems like there's going to be counterpossibles involved in interpreting these models counterfactually. And if that's the case, then that will mean that the counterfactual interpretation comes apart from the how possibly interpretation. There's going to be things that are strictly speaking metaphysically impossible. Okay. So this isn't to say that the views haven't gotten conflated. They sure have. But I think that these are important reasons to treat these as separate views, especially the difference in content. And so what I'm going to focus on throughout the talk is this difference in content and saying why we should prefer one interpretation of their content rather than another interpretation. Okay, so here's my goal throughout the talk is to defend the counterfactual interpretation. I'm not going to do this. I don't want to, and I'm not trying to defend the implausible, crazy view that representation of mere possibilities never happens in scientific practice. It happens all the time, right? One of the reasons why I think this literature is so messy is that people just mix and match examples. One of the examples that people stick to is Schelling's how possibly models of segregation. But Schelling explicitly says, I'm not trying to represent actual worlds. I'm trying to, actual systems. I'm trying to represent how something merely could happen. Of course, if you pick a scientific model that was designed to represent a possibility, then that's what its content is. I'm not going to try to pick a fight about that, because of course that's what it is, right? And Michael Weisberg's 2013 book has some great examples of models like these. My goal instead is to argue that the familiar puzzle that we've all heard before doesn't provide any special reason to think that in cases of extreme idealization, the model's content is mere possibilities. And I'm going to show that there's some other reasons we should favor the counterfactual interpretation. So I'm going to defend the counterfactual interpretation by undermining reasons to believe the how possibly thesis, as well as giving some other broader reasons to favor the counterfactual interpretation. Okay, so does the familiar puzzle adequately motivate the how possibly thesis? I'm going to say no. There's going to be three broad reasons. There's, first of all, and this is the most important reason, there's no special reason to think that highly idealized models can't have actual systems as their targets. Secondly, according to some of the purportedly good reasons to endorse the how possibly thesis, the view that their content is mere possibilities, we should actually conclude that the how possibly thesis is false. And then lastly, there's going to be, as we'll see, no epistemically significant difference between the purportedly how possible models and other idealized models. All right, so let's get started on the main point. So there's no special reason to think that highly idealized models can't have their actual can't have actual systems as their content. That is, there's no special reason to think that highly idealized models can't be targeted at the real world. And the way I want to get started arguing for this is just by asking, in general, how does scientific representation work? Well, obviously, you're going to have to pick your favorite view of scientific representation, but I'd like to argue that no matter what view you pick, there's no special reason to think that highly idealized models can't have actual systems as their targets. Here's a disclaimer. A lot of what I say here is going to be inspired by a paper that James Nguyen wrote in BJPS, I think came out last year. So if you'd like to read more about this, please read that paper. But here's the basic strategy. Look, there's three prevailing accounts of scientific representation. I'm going to pick inferentialism to start with because it's the correct view and it's my view. But here's what inferentialism about representation says. Inferentialism says that here's how a model has a particular content. A model has a particular content by just being a surrogate for the target whose content it is, or for that targeted content, right? So you've got an animal model of, say, depression, that's a rat, or the nervous system of a rat, and then you've got the actual target. Why is it that this is a target, that this has the actual brain as its content? Oh, because we're using it as a surrogate. So it's a pragmatic use-based notion of scientific representation. And here's what's key, that facts about the model get interpreted as facts about the target. And that's, here's the example again. How do we use the animal model of depression? Well, we just, interpret facts about the rodent brain as facts about the human brain. That doesn't mean that the representation is accurate. It just means that that's what the representation's content is. Okay, so on all inferential views of scientific representation, all that's really eventually required is that a model has a particular, all that's really required eventually for a model to have a particular content in the real world, for it to have a target in the real world, is just for there to be some interpretation of the model in terms of the target. Obviously, I'm simplifying here because we don't have limited time, but that's, every view basically has that in common. And here's what I'd just like to ask, like, why wouldn't this be possible for especially highly idealized representations? Like, who cares that the model says that the predator and prey have infinite appetites? All that you need to do to get the model to represent the target is just to say, by these elements in the model, I hereby denote these elements in the target. It doesn't have to be accurate, it just has to have that as its content. So here's the broader point, and this is an instance of a more general point. All I'm saying here, all I'm defending, is that it's possible for the content of the model to be an actual system. I'm not defending the claim that it's possible for these to be accurate representations, but that's not what we were concerned with at all, right? The how possibly thesis and the counterfactual interpretation, they don't differ with regard to, whether they think these models are accurate or inaccurate. What they differ with regard to is what they think the content is. But if we take this view of scientific representation, it seems like there's no obstacle for the content of the model to be an actual system, putting aside whether the model is or isn't accurate. So here's the more general point. We should be careful not to conflate accurate representation with representation to core, right? Like, just because the models are highly unrealistic doesn't mean that they can't possibly have real targets as their content. They maybe have real targets as their content. They're just bad models of them. We think that there's bad models all the time. Why can't we say that about unrealistic models? Again, it seems perfectly plausible for a representation R to have content C, even if R misrepresents C. We shouldn't say that a representational device R has content C if and only if it represents C accurately. Here's the stock example of people working in scientific representation. Inaccurate maps still have actual systems as their targets. No one ever said, here's a bad map of the London Underground. It represents a merely possible London Underground. No, you all agree that it represents the actual London Underground badly. Its content is still an actual system, even if it's unrealistic, even if it's inaccurate. Let's get to other accounts of scientific representation, and I'm realizing now that I probably have to speed ahead a little bit. Even on other accounts of scientific representation, there's no special reason to think that these idealized models can't be directed at the actual world. So take like an isomorphism or homomorphism account of scientific representation, according to which a model represents by way of structural similarity. Well, if that's the case, this is usually specified in terms of whether it's structurally similar to relevant factors, right? Whether you have partial isomorphism to the right parts of the target, whether you have partial homomorphism with regard to the right target, to the right parts of the target. Same thing with qualitative similarity accounts, right? Like no one's gonna say that a rat brain is qualitatively similar to core to a human brain, but everyone will admit that, oh no, look, it represents because it's similar in the relevant respects. So the first reason that the familiar puzzle arises is because people are complaining about how unrealistic these models are. But despite these models being unrealistic, there are plenty of contextually relevant ways in which the idealized systems are very similar or isomorphic or whatever you want to their actual counterparts. Let's pick a non-toy model example. Like fluids couldn't be perfectly continuous, but actual fluid flow is really similar to ideal fluid flow. Predator-prey populations couldn't be infinitely large or contain fractions of hawks and doves, but in contextually relevant ways, the population behavior of predators and preys is really similar to the Lacan-Volterra model. So according to some of the purportedly good reasons to endorse the how possibly thesis, which were these, look how unrealistic they are. They can't possibly represent real targets. The only way they could represent real targets is if and only if they were similar. But they are similar in the right ways, right? Like in the contextually relevant ways. But they are similar if we just like are specific enough. So it seems like in the right conditions, there really are the kinds of factors that facilitate representation regarding actual targets by the same accounts of representation that support the how possibly thesis. Okay, so I conclude overall, so far, there's no special reason to think that these especially unrealistic models can't represent actual targets. Again, I'm not defending the claim that they're good representations of actual targets. I'm just defending the claim that it's possible for their content to at all be an actual target. And that's why. Here's a second point, or the next point that I want to make, which is just this. There's no epistemically significant difference between the purportedly how possible models versus other idealized models. And I think the easiest way to notice this is just at the beginning when we were presenting the familiar puzzle, I noticed like we observed that this is a puzzle that you're all familiar with, that like we're all familiar with this puzzle of like, how is it that an idealized model can provide any epistemic good regarding an actual target? And let's just observe that no one complains. I mean, okay, some people complain, but like for the most part, we've gotten okay with this idea that when it comes to quote unquote ordinary cases of idealization, like the ideal gas law, mostly people are now okay with the idea that the ideal gas law represents real gases. No one's out there saying, oh, the ideal gas law represents merely possible gases. So why is it the case that all of a sudden, when we move to something like the Lacan-Volterra model, this is just another instance of the same puzzle? Why is it that all of a sudden now we're saying, oh, the Lacan-Volterra model represents merely possible populations? If the answer is that the Lacan-Volterra model represents merely possible populations, it doesn't seem like there's a significant enough difference between the kinds of idealizations that are involved to justify a representational difference. Like, what's different between them? Yeah, the Lacan-Volterra model says there's infinitely large populations. You can have fractions of a hawk or dove, whatever. The ideal gas law says there's, infinitely small point masses that transfer kinetic energy perfectly elastically. Those sound to me, at least, equally crazy as far as idealizations go, right? It doesn't seem like there's a significant epistemic difference between the kinds of idealizations that would justify saying that this model represents actual gases and these models represent merely possible populations. Now, maybe you think that there is an epistemic difference extrinsic to the model. Maybe you think, and here's, this is Alex Rutlinger, Stefan Hartmann, and Dominic Hongleiter in 2018 saying that, look, here's an epistemic difference, that there's embedded toy models that are embedded in a broader, well-confirmed theory, and toy models that aren't embedded. And maybe you think that the difference between being embedded in a broader theoretical context versus not being embedded in a broader theoretical context, being what they call autonomous, maybe you think that's enough to be like, okay, look, the Locke-Volterra model, according to them, is autonomous. It's not sufficiently embedded in theoretical ecology, which I think that's actually false if you ask a bunch of theoretical ecologists. But supposedly, here's an epistemically significant difference. And I want to say that this supposed epistemically significant difference isn't epistemically significant. Here's why. What if a model that weren't sufficiently embedded in a broader theoretical context were to become embedded? So according to this objection, here's an epistemically significant difference between the how possibly idealizations and the non-how possibly idealizations. The how possibly idealizations just aren't sufficiently embedded. But what if they were? Okay, and here's eventually where we should favor the counterfactual view, because if we have the how possibly view, we have a really unnatural view of model formulation and testing forced upon us. Here's what I mean. Okay, so imagine just for a second that so basically suppose for reductio, right? Suppose for reductio that the how possibly thesis is true, that the content of the Locke-Volterra model, what it represents is merely possible populations. They don't even care about real populations. In many cases, highly idealized, these kinds of toy models might get formulated as first hypotheses about how particular actual systems work. And this is corroborated by recent work on exploratory modeling, right? People haven't really started paying that much attention to exploratory modeling until recently, but I think a lot of the time we formulate highly idealized models as sort of initial hypotheses, as initial heuristics to guide further model formulation. And here's some more examples of this, right? Like we had a bunch of models of star collapse, a bunch of models of the structure of the atom, a bunch of models of COVID, and so on. And so imagine that you've got this view, right? Here's some not yet embedded toy models, some not yet embedded highly unrealistic models. And suppose you say what this represents is how star collapse could happen. This is a how possibly model. Could, again, not as an epistemic possibility, but as an epistemic and as a metaphysical possibility. But I think this reading gets really strange when we start noticing that these models get formulated as first hypotheses, right? If we treat models as not as models, but as hypotheses or as other epistemically similar bits of theory, wouldn't it be weird to say this, that when we formulate an initial model, it's only about an objective possibility, and then we continue to test it, and then, oh, we find out that it's false? Wouldn't it be weird to say that that model that's superseded is still a very accurate representation of how things could be? That'd be kind of weird. Here's a much more natural reading. We've got a bunch of superseded scientific models of XYZ, the atom, star collapse, whatever. And instead of saying that these are still to this day very accurate representations of how star collapse or whatever could happen, it's much more natural to say that these are just models of how things actually happen that just turned out to be false. And what that view tells us is that, hey, look, something like the counterfactual interpretation is correct. There's an actual target as its content. It just happens to ascribe counterfactual information to it that turned out to be false. Let me put this a different way. The how possibly thesis forces a really strange interpretation of exploratory models. Before we confirm or test the models, what the models represent is genuine objective possibilities. And then we confirm or test them, and then the target switches over. like once we confirm the model enough, like the model switches over from representing merely possible ecosystems to representing actual ecosystems. Like we don't want to like conflate epistemic and metaphysical possibility. It's really unnatural to say that this like switching over happens. Put it this way, if there is a difference in whether models represent an actual target versus a merely possible target, that difference in content shouldn't be due to the mere extent of empirical support. And again, I know that like there's people writing on how possibly explanation, and there's a tradition there that says that the only difference is empirical support. And I want to say, look, that just conflates epistemic possibility with objective or metaphysical possibility. So let me kind of speed ahead the rest. Here's the last point. The last reason I think we should favor the counterfactual view is this. And in many ways, I think this is actually the most powerful reason. Is there a reason to think that these idealizations constitute genuine possibilities? Well, we're told by defenders of the how possibly thesis that what like the Locke of Volterra represents is actual genuine possibilities. There's an actual objective possibility out there. There's an objective possibility that there's like you know, an infinitesimal rabbit being preyed on by an infinitesimal hawk or whatever. I'm borrowing from Brian's language there about Thumper the infinitesimal rabbit. Like these idealizations seem like they're awfully impossible. It seems awfully impossible that there could be that there even could be a Locke of Volterra system. It seems awfully impossible for there to be any of these supposed possibilities. Point masses, fractions of rabbits, etc. Like the answer that the how possibly thesis seems to force is this. These models represent genuine possibilities, and it really is genuinely possible for there to be a fraction of a rabbit. But it's not metaphysically possible. It's not nomically possible. It's certainly not epistemically possible. So whatever sense of possibility there is here, it's got to be something that even metaphysicians aren't aware of yet. And now I'm a metaphysician, so I'm no stranger to spooky modality. But like even for me, like that seems like a bridge too far. I know Philippe, you're in the participants, and I anticipate an objection about this. So if you want, you can fight me about this. Okay, so this seems sketchy. It doesn't seem like there's any sense in which the how possibly thesis could represent genuine possibilities. Here's a much more empirically friendly metaphysics of modality, at least compared to that. And this is going to be the last point, and I'll wrap up. Forget the idea that it's genuinely possible for there to be an actual, sorry, not actual, that there's some metaphysical possibility or whatever that corresponds to a genuine Locke of Volterra system. There, like, who knows the way in which it's possible for there to be, perpetual motion machines, infinitely large populations and so on. There's no genuine possibility that it represents. All that the model tells us is this: if predator-prey populations were like thus and so, they would behave like coupled differential equations. Now, this is still modality, right? It's still modality. It's still something that points beyond the actual, but it's less spooky. Why should we think that it's less spooky? Well, again, we don't have to like invent a new kind of possibility to account for the way in which these things are possible. On the other hand, also, why should we think that this wouldn't just be the same as representing a possibility? Well, the short answer is this: if there turn out to be counterpossibles, then there's going to be cases where the counterfactual interpretation will represent something as, will give us some modalized content that doesn't correspond to a genuine possibility. So that's the short answer. I'm happy to talk about that more if you like. This is still modality in the world, right? Like you still would have to agree that there's, when it comes to like a successful model, we still learn something like, oh, like it turns out really that like if predator populations really were, infinitely large and blah, 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 they would behave like this. Like this is still modality in the world. And maybe you think it's still metaphysically spooky, But no matter how spooky it turns out to be, it's still a lot less spooky than the one where we have to say, yes, the model represents a genuine possibility, and yes, it really is genuinely possible for there to be an infinitesimal rabbit. Like, if I'm choosing between spooky things, like it's like the counterfactual, the counter possible is way less spooky than it being objectively possible for there to be an infinitesimal rabbit. And so let me speed ahead here. So basically, let me summarize what I've done. There's a puzzle regarding their content, right? Regarding the content of highly unrealistic models. We could interpret them as representing mere possibilities. I've argued that that's false. We should instead take these to represent actual systems, but in ways that ascribe counterfactual properties to them. And that's it. Okay, sorry for going over time, and that's it. Thanks, guys.